Okay, so we're gonna start with lecture 6. In this lecture, we're talking about lines and linear equations, right? So linear equation is another way for us to say, okay, we want to look at the lines. Okay. So the learning objective of this lecture is to calculate and interpret the slope of a line, determine the equation of a line given 2 points, right? Express an equation of a line in slope intercept, point slope form, and or standard form. So there are three main forms of equation of a line that you can use. The first one is the slope intercept form. The second one is point slope form, and the last one is the standard form. And we will go over all of this form later on in the lecture. We will write down the equation of vertical line and horizontal lines, and we determine the equation of parallel and perpendicular lines. Okay. So that's what we want to cover in this lecture. There's a lot to cover in this lecture. Can you let me know how many of you have seen these materials before? So a lot of you. Okay, so good. So let me write down the equation of a slope given 2 points, right? So let P equal to x1, y1, and Q equal to x2, y2 be two distinct points. And we say that the slope M of a non-vertical line containing P and Q is, right, so the equation of the slope is M equal to y2 minus y1 over x2 minus x1. All right. So the equation of the slope of a line going through 2 points given in this formula. And this is a fractions. Again, when you see fraction, you don't want the denominator to be equal to 0. So therefore, you impose the conditions that x1 has to be different from x2. We will consider a case where x1 equal to x2 later on in the next few bullets. But for now, in general, the equation of slope of a line, a non-vertical line going through 2 point P and Q is given in the form of y2 minus y1 over x2 minus x1, given that x1 is different from x2. Okay. Now, if x1 equal to x2, what's going to happen? So when x1 equal to x2, you see right here, right? You have 2 point P and Q, x1 and x2 are the same. Or we just have one x. Okay. So when that happens, you have a vertical line. So if x1 equal to x2, L is a vertical line. Do you have a question? Yes. Now, when you consider slope, most of you see the formula that the slope is equal to the rise over run. So the slope can also be described as rise over run. And rise over run, there's another concept that you can relate to the slope. It's called the average rate of change. Okay, that is, the numerator is the change in y value and the denominator is the change in the x value. So this can also be described as change in y over change in x. All right, so usually we use notation to describe mathematics. Yeah. So the slope, we use the letter m, right, by convention. We use m for slope. The change in y, usually we use delta y, and the change in x, we use delta x to describe. So here the notation is delta y over delta x. So the formula to calculate the slope can also be used to calculate, again, something called average rate of change. So delta y over delta x is also equal to something called average rate of change. Right. So I can ask you the questions that what is your velocity, what is the velocity when you drive from home to school, right? So that is, you have the rate of change or the change in the distance over the change in time. And if you do that calculation, then you have the average rate of change of the location with respect to time, or in short, that is the average velocity. Okay. And you will see this concept again at the beginning of calculus 1, when they use the idea of average rate of change to derive something called instantaneous rate of change. But that's for calculus 1. All right, so you have 3 figures here just to demonstrate the idea of the slope of a line connecting to 2 points P and Q. Again, the slope can also be written as rise over run. When the x value are the same, you have a vertical line. Okay. Right. Again, the last picture is rise over run formula. Now, for example 1, we're going to apply the formula of the slope to calculate the slope of the line going through 2 points. All right. So given the point 1, 2 and the point 5, negative 3, we can find the slope of the line going through these 2 points. So m is equal to y2 minus y1 over x2 minus x1. Right. So given that, let's say this is x1, y1, this is x2, y2. So you have negative 3 minus 2 over 5 minus 1, so negative 5 over 4. So you calculate the slope, and the slope give you negative 5 over 4. So this is less than 0. The value of the slope means something, right? And we will look at the different value of the slope. Is that positive, negative, equal to 0, or undefined later on, to identify the type of line that we have. Okay. Any question on example 1, the first example? Good. Now let's move on to the second example. You have 2 points that have negative 1/5 and then 2/3, 1/5, and you calculate the slope of this line. So m is equal to, again, y2 minus y1 over x2 minus x1, given that this is x1, y1, x2, y2, and you get 1/5 minus negative 1/5 over 2/3 minus 1/2. Can you do a quick calculation for me, please, and give me the answer? Let's start with the numerator. What do you get for the numerator? 2/5, right? What is the denominator? Did somebody say something? 1/6, yes. All right. So when you divide a fraction, that means you can multiply it by the reciprocal. All right. So 2/5 times 6/1 give you 12/5. Now this one is a positive number. No, it's fine. Just give me the answer. I want to build up something for later concepts. All right. Any question on example 1? Good, straightforward. All right. In example 2, you have different scenarios here. You have the point P and 4 different points on Q. So can you plot this point on the XY plane? So the point 2, 3. So this is P. Q, the first Q is -1, -2. So this is Q. So I use red for the first line. Now for the second line, the Q value, the point Q is 3, -1. Right, so this is line 2. This is line 1. The third line, 5, 3. And the last one, the point is Q. The point Q is 5, 2, 5. So this is line 4. Now, can you calculate the slope of each line? So that means you need 4 different calculations here. You got the idea? Any questions? Any questions? All right, so for the first line, the slope, I call that M1 is equal to -2 minus 3 over -1 minus 2. So I have -5 over -3. Well, this is 5/3 greater than 0. So let me change this to color red to match up with the line that we use. The next line, line 2, is in purple. So M2 is equal to -1 minus 3 over 3 minus 2. So this is -4/1, -4, which is less than 0. The third line is in orange. So you do M3 equal to 3 minus 3 over 5 minus 2. Let's give you 0 over 3, which is 0. And the fourth line is the vertical line. I have M4 equal to 5 minus 3 over 2 minus 2. Just give me 2 over 0. What is my conclusion here? 2 for 2 over 0. Undefined, right? So the answer here should be undefined. That's the conclusion. All right. So the sign of the value is that positive, negative equal to 0. Undefined means something for the line. Okay. So when the slope is positive, you have the line. So m greater than 0, the line slants up from left to right. Because when you read a graph, you always read it from left to right. All right. So when the slope is positive, the line slant up from left to right. So you look at the red line, just go up, right? And up from left to right. When m is less than 0, have the line slant down from left to right. When, right, so it match up with the purple lines, the line is going down from left to right. Okay. Now, when the slope is equal to 0, the line is horizontal. Right, or you have a horizontal line. And for the last case, when the slope is undefined, so m is undefined, you have a vertical line, or the line is vertical. You good with this 4 scenarios on slope? Okay. Now you have a slope. If I give you another point, can you write down the equation of a line? The answer is yes, right? Using something called the Poisson form. And then using the Poisson form, you can manipulate the equation to turn it into something called the slope intercept form, or you can manipulate it to turn it to something called the standard form or the general form. For the Poisson form, it has the form y minus y0 equal to m times x minus x0. Given that for this equation, you have something called m, which is the slope, and you have x0 comma y0 is a given point. Or point on the line. So this form is very convenient for you to start, given that you have a slope and a point. Okay. Again, I mentioned earlier that you can manipulate the equation of the line in Poisson form to arrive at something more convenient for you to graph. This is called the slope-intercept form. You have y equal to mx plus b. For m, again, is slope. B is called the y-intercept. And the last form, usually we don't use that much on this form. It has actually the form of capital capital A times X plus capital B times Y equal to capital C, where A, B, and C are constants. You see more of this general form or standard form in the case of system of equations. Unfortunately, we're not going to cover that in this course. Right. So because of that, most of the time in this course, you will see the point slope form and the slope intercept form. Okay, now let's start with the slope intercept form. If m is equal to 0, right, in that scenario, you have the horizontal line. Therefore, the equation of a horizontal line is just y equal to the y-intercept. Go with me. Okay, so y equal to b is the horizontal line. Y equal to b. M in this case is equal to 0, and b again is the y-intercept. Right, so y equal to what? Y-intercept, because the horizontal line always cut the y-axis. You with me on that? Okay. Now for vertical lines, you have x equal to a constant a. In this case, for vertical line, the slope is undefined. And a in this case is the x-intercept. So the x equal to a, the vertical line always intersect or cut the x-axis. Okay, any questions so far? All right. Now, let me jump to some examples here. So for example 3, find an equation of a line of slope 3 that goes through the point 1, 5, and then at the end, can you express it or the equation of a line in the slope intercept form? Okay. Now in this problem, let's analyze this. You are given the slope, value of slope, which is positive 3, and a point 1, 5. So therefore, it's a good start for us to use point slope form. So you start with y minus y0 equal to m times x minus x0. So again, this is the point slope form. Given that the slope is equal to m is equal to 3, and the point x0, y0. Right? So x0 equal to 1, y0 is equal to 5. So you substitute these given values into our formula. I have y minus 5 equal to 3 times x minus 1. Normally, this should be fine. We finished finding the equation of a line, but by the look of the example that you need to turn this form into the slope-intercept form. And again, the slope-intercept form is y equal to mx plus b. So we need to turn that into this form. So what we do is we try to solve for y by itself. That means at this point, you can move -5 to the right-hand side. You get y equal to 3 times x minus 1 plus 5. And then you can distribute 3 into the parentheses. You get y equal to 3x minus 3 plus 5, or y is equal to 3x plus 2. And this is the slope intercept form. Any questions? Yep. All right, so let's move on to example 4. So in this example, what you have is you want to find equation of a line, but going through 2 points, 1, 5, and 2, 3. So you are given 2 points. You weren't given a slope, right? So you need to find the slope of the line given 2 points. So the slope m is equal to what? y2 minus y1 over x2 minus x1. Right. So I choose x1, y1 for this point and x2, y2 for this point. Therefore, the slope is calculated as 3 minus 5 over 2 minus 1, or this is -2 over 1, or it's -2. Now you have a slope. You can choose one. All right. You can choose one of the point given to you here, and then apply or substitute this value into this point slope form. Okay. So given m equal to -2 and the point x1 comma y1, we get that y minus y1 equal to m times x minus x1. So the formula that we see earlier on the point slope form, right? So I give you y minus y0 equal to m times x minus x0. So the value of x0, y0, right? This is just a placeholder. You can change this to something else. In this case, you can change this. This can be written as y minus y1 equal to m times x minus x1. It means the same thing, okay? Or you can write y minus y2 equal to m times x minus x2, right? So x0, x1, x2 means the same thing in this context. y0, y1, y2 means the same. We good? Okay. So you have the point slope form. So y minus y1, which is 5, equal to m, which is -2, times x minus x1, which is 1. All right. Now that is this point slope form. You want to turn this into the slope intercept form. So that is y equal to -2x plus 2 plus 5. And therefore, you get y equal to -2x plus 7. And this is the slope intercept form. Any questions? Good. All right. Now we move on to another concept called parallel and perpendicular lines. So for if you want to know if two lines are parallel or perpendicular or not, you're going to follow the following properties. So for parallel lines, let's try. So consider two lines, y equal to m1x plus b1 and y equal to m2x plus b2. So these are two different lines. Now the two lines are parallel if m1 equal to m2 if they have the same slope. And b1 different from b2. Right. So I need an extra conditions here because if b1 equal to b2, then it's just two lines on top of one another. But the important condition is that the two slope needs to be the same. Now for perpendicular lines, consider two different lines. Again, y equal to m1x plus b1 and y equal to m2x plus b2. Now to see if the two lines are perpendicular or not, you need to take the product of these two of the two slopes, and if they're equal to -1, then the two lines are perpendicular. So m1 times m2 equal to -1. Or you can solve for m1 from here, and you get m1 equal to -1 over m2. Or you can solve for m2, which is equal to -1 over m1. So either one of these formulas should be fine. All right, so let me recap this quickly. So the two lines are parallel if the slope are the same and their y-intercept are different. The two lines are perpendicular if you take the slope of two lines, multiply them together, you get -1, then they are perpendicular. Let's do some examples now. So for example 5, you want to write the equation of a line going through the points -1, -a, and parallel to the given line y equal to 5x minus 2. Okay. Now what I do is I consider the line L of the form y minus y0 equal to m times x minus x0. And this line that I'm looking for is parallel to y equal to 5x minus 2. Okay. So the two lines are parallel, implying that the two slopes should be the same. In this case, you can deduce that m is equal to 5. You're okay with that? Okay. So this shows that m is equal to 5. Now, since m is equal to 5 and L is going through -1, -8, we get that y minus -8 equal to 5 times x minus -1. Now, this is the equation of the line that we need to find. So this is the equation of the line that going through -1, -8, and parallel to the given line. Because there's no request to turn this into the slope-intercept form, this is a good answer. You with me on that? Okay. But let me manipulate or simplify the equation a little bit. So I get y plus 8 equal to 5 times x plus 1. You okay? Yeah? Hopefully you follow my analysis and understand where's all the information coming from, where's all the number coming from. Right. Any questions? Right, so let's do example 6. Now I want to write the equation of a line perpendicular to the given line x minus 3y equal to 9 and intersecting the y-axis at 5. Okay. So you're looking for an equation of a line, right? So consider the line y equal to mx plus b, right? That is perpendicular to x minus 3y equal to 9. And intersects the y-axis at 5. All right. You may wonder why I use this form, slope-intercept form, instead of the point-slope form earlier. So I use this form y equal to mx plus b because I recognize in my example the information is given to me that the line is intersecting the y-axis at 5. So I can automatically obtain the value of b. The only thing that I need to look for is the slope m. You okay? Okay. So because the line that I'm looking for intersect the y-axis at 5, so the value of b is automatically given. So b is equal to 5. Then you have that b is equal to 5. Now you need to find the value of m. Okay. Now remember, another piece of information given to you is that the two lines are perpendicular. So the product of the two slopes should be equal to -1. But the lines that we consider should be in the form of y equal to m1x plus b1 and y equal to m2x plus b2. Okay, so you need to turn this given line x minus 3y equal to 9 into this form. Okay, so next we do x minus 3y equal to 9, you turn it into a slope-intercept form. So that is -3y equal to -x plus 9 And then to get y by itself, you divide both sides by -3. You have -1 over -3x plus 9 over -3. So y is equal to positive 1/3 x minus 3. You got it? From the given line, I change its form into a slope-intercept form. You okay? You understand where it's coming from? Okay. So again, what I just did is I turned this general form or standard form into the slope-intercept form so that I can extract the slope of the line. Okay. Now I have the slope, and then the two lines are perpendicular. Since the two lines are perpendicular, we have that m times 1/3 is equal to -1. Or so again, the two lines are perpendicular, implies in that product of two slope is equal to -1. So m times 1/3 is equal to -1. Therefore, m is equal to -3. Right. So the equation of the line is y equal to -3x plus 5.